Okay, hi everybody. In this screencast, I'm going to be doing two things. I'm going to be reviewing transformations of functions that you saw last year, and then I'll be adding on to those transformations to show you two new transformations, and then I will be tying all of that back to our conversations about domain and range, okay? All right, so let's just begin. So what I start off here, I just wrote down the ones that you have seen before in the past, okay? So I know last year, after speaking to your Math 2 teachers, I know that last year, when you had a function, you knew how to translate vertically or shift a function up and down vertically. And specifically, you saw that when you were given a function f of x plus a constant shifts f of x up k units, f of x minus a constant shifts f of x down k units, okay? And so I gave an example over here, here we go. I said sketch f of x equals x squared and sketch g of x equals x squared minus 7. This is just reasonable accuracy, okay? And maybe one thing that you're seeing right now is that you notice that that g of x could be written as just f of x minus 7, right? Okay, so g of x is just f of x minus a constant. So what if I go ahead and graph these, and if I graphed f of x as x squared, and reasonable accuracy is all we care about right here. This is f of x equals x squared. Maybe you could label some points like 0, 0, 1, 1, negative 1, 1, what have you. G of x would take f of x and shift it down 7, okay? So that this vertex here of the parabola would be 0, negative 7. If this was the point 1, comma 1, maybe you'd say this is the point then 1, comma negative 6, and similarly negative 1, negative 6, okay? So I know vertical translations you've seen before. And what's interesting is when you're given sometimes a function f of x and a function g of x to sketch, it's helpful to think about, g of x in terms of f of x. So I did here in purple, all right? Then you also did last year shifting f of x left and right, or they're called horizontal translations. Translations, another word for just a slide or a shift, okay? And you saw last year that if you give it a function, f of x plus k. Now notice the difference here, that the plus k is actually within the input, okay, which was not the case up here with, see how the plus k was not part of the f of the x of the input of f, okay? So you saw last year that f of x plus k shifts the function left, and yes, people often forget that with horizontal shifts, it's kind of like the opposite of what you'd think, and I know that you talked about why that was the case last year. If you don't know why that's the case, I can tell you why when I see you, but just let me know, all right? And f of x minus k shifts the function right k units. So here's another example here. Given f of x equals the root of x, sketch f of x equals the root of x, and g of x equals the root of x minus 3 plus 2. Now, once again here, what I'm going to do is I'm going to take g of x and express it in terms of f of x using just function notation, and you'll see that, you would hopefully see that g of x is the same thing as just f of x minus 3, right? And then the plus 2. The plus 2 here is not part of the input. And what this tells you then is that the plus 3 means we're going to shift right 3, and then the plus 2 means you're also going to go up 2 units. So this second example has two transformations, a horizontal translation and a vertical translation. So maybe you'll go over here and sketch f of x equals root x. Again, reasonable accuracy. Okay, 0, 0, 1, 1, 4, 2, what have you. And we're going to shift the whole thing right 3 and up 2 units. So right 3 and up 2 units, okay? So this point here becomes the point 3, comma 2, That's the translation of 0, 0. Right 3 and up 2 units, maybe you'll do, this is the 1, 1. If this was the point 1, 1, which it is, right? Shifting it right 3 and up 2 units will give you 4, 3, right? And maybe there's the translation. Okay. Naturally, when you have a transformation like this, right, a transformation of this function f changes the domain. In other words, the domain of g of x and the domain of f of x are not the same, right, as you can see. Sometimes transformations change the domain, sometimes they don't. And here, if you look at this, the domain of g is the same as the domain of f, but the range is different, okay? So transformations do affect sometimes domains and ranges. The last transformation you saw last year was the reflection over an axis, okay? And specifically what you saw was that if you were given f of x, negative f of x reflects the function over the x-axis, and f of negative x reflects it over the y-axis, okay? So this one's going to be interesting. So here, if you look at this example, I said sketch f of x equals the absolute value of x, which we know is the v, okay? And again, maybe you'll label some points, 0, 0, 1, 1, 2, 2, negative 1, 1, negative 2, 2. Well, let's see what's going on here. This g of x is negative the absolute value of negative x plus 3. And again, I'm going to use function notation here. G of x is the same thing as negative f of negative x, right, plus 3. Okay, and when you have multiple transformations going on here, you do want to obey the order of operations. And what that means, what I tell students it means is to look at x and then take the operations in terms of the operations being done to x. So x is being negated here, and then f of x is being negated, and then you're adding 3. So what's important here is, let's take it step by step. The first thing that's happening is it's a reflection over the what axis, boys and girls? Reflection over the y-axis. That's the first thing that's happening. But you'll notice that if I reflect this function over the y-axis, it lands on itself. So I lucked out. This negative is saying to then reflect over the x-axis. Reflect over the x-axis, okay? Reflect over in the x-axis. I'm just going to do that here, dotted, because I'm not done yet. So now I just reflected over the y-axis, and I reflected over the x-axis. That's where I land. Now I want to make sure I deal with the vertical translation up. This is saying I want to then move everything up 3. And notice again how I'm going in the order of operations. And I want you to take that order as what is being done to the x, okay? X is being reflected. You think of the order of transformations in terms of what is being done to the x. So reflect over the y-axis, reflect over the x-axis, then move up 3, okay? Then finally, I am going to do my final. Dink. Woo. Okay, there's my final picture. All right, so these 3 transformations, reflections over the axes, horizontal translations, and vertical translations, that is a comfortable review for you, okay? Let's talk about 2 new transformations that will be new to you. One is called, the first new one is called a vertical stretch or shrink, okay? Or what's called a vertical scale change, okay? So this is new for us, a vertical scale change. All right, so let me show you the transformation. Let's write it down first. This transformation says that if you are given f of x, okay, and if I multiply f of x, which is y, by the way, right? If I multiply y by some constant, okay, this will vertically, it out. Okay, when you have a function and you're multiplying it by some constant, the effect is either a vertical stretch or a vertical shrink by a factor of k. What this means in practice is the following, or, okay, each y coordinate, okay, or I'll say let's say right, the y coordinate, that sounds better. Okay, the y coordinates are multiplied by k. So let's do an example, okay? Let's do an example. And this may be something you've seen last year. I didn't ask your teachers about this one, but let's just see what happens. Let's just do our old friend y equals x squared, or f of x equals x squared. Okay, so let's take a look at f of x equals x squared, and let's go ahead and sketch this. And this one I'm going to do with reasonable accuracy here. So you see I lined up my axes really nicely. Okay, okay, so I want to be a little bit more precise. Okay, so here's my question for you. So it's point like 2, 4, okay, 1, 1, this is negative 1, 1, etc. Okay, well, let's take a look at this one, shall we? Let's say you were looking at this one. Let's say you're looking at g of x, which is equal to, let's make it 1/4 f of x, okay, which would then make this 1/4 times x squared, okay? So the effect of this value right here, the effect of this is k times f of x, means that every y coordinate, or y in general, is going to be multiplied by 1/4. So what happens is 0, 0 will stay the same because the y coordinate of 0 times 1/4 remains 0. But 1, 1, look what happens. 1, 1 becomes 1, 1/4. And negative 1, 1 becomes negative 1, 1/4. 2, 4 becomes 2, 1, and negative 2, 1. And if we can do more points, certainly, but look what happens. Okay, the effect here is that this 1/4 times f of x results in what's called a vertical shrink or a vertical compression. Okay, vertical compression, vertical shrink, okay, vertical scale change by a factor, vertical scale change by a factor of 1/4, okay? All of these phrases are synonymous. And if you look at the parabola, what happens is it has kind of shrunken vertically. Now, I know some of you are looking at it and saying, Miss Yam, isn't a vertical shrink considered the same thing as a horizontal stretch? And the answer is yes, okay? But it's not always obvious what that connection is. And I'll talk about that a bit more later on, not quite this second, okay? So I guess I could ask you too, I could ask you this question. Given now the generalization that we've made, which is that k times f of x results in a vertical stretch or shrink, tell me what value of k will result in a vertical scale change that will not modify f of x at all. Yes, if k equals 1, right? If k equals 1, then there's no scale change whatsoever. But if k is between negative 1 and 1, right? So if k is between negative 1 and 1, right? So I'm asking you to kind of think a little bit. If k is if k is between 1 and negative 1, is it a vertical stretch or a vertical shrink? Yes, it's a vertical shrink or vertical compression. Now, you know if k is negative, it'd be a vertical compression and a reflection over the x-axis, right? Okay, what if k is bigger than 1, or if k is less than negative 1? what's going to happen is a vertical stretch, okay? Or in this case, the parabola would get really long and skinny, right? And of course, again, if k was negative, it also involved a reflection. So that's a vertical scale change, all right? Naturally, let's go to the last transformation, which is a horizontal stretch or shrink. Okay. Horizontal scale changes. Okay, or again, horizontal stretches or shrinks. Okay, so just like, when we did scale change, when we did translations, like, whenever you're modifying, whenever there's a transformation that affects x, it's always kind of like opposite of what you thought, right? Like the whole plus k is left, minus k is right. And remember, if you don't know why that's the case, tell me, I'll tell you in class, okay? You may see or predict that with a horizontal scale change, something similar happens, and it does. Let me write this down first. Okay, so here is the result. It says the following. It says, given f of x, here's what happens. F of kx, okay, results in a horizontal scale change. So I'm purposely going between different vocabulary words, okay? Of a factor of, here it is. So the scale change is not a factor of k, it's a factor of 1 over k, all right? Or in other words, okay, x, the x coordinates of f of x are multiplied by 1 over k. So let's do an example. Let's say I want you to sketch the following. Let's sketch f of x, which equals x cubed. And I also like you to sketch, okay, let's sketch f of x equals x cubed, and let's do g of x, which equals, okay, 1/3 x cubed. Okay? All right, well, similar to what we've been doing, what I'm going to do here is express g of x in terms of f of x, right? Okay, g of x is just this, the result of f of 1/3 x, right? Okay, and right away I know that f of 1/3 x is going to result in a horizontal scale change factor, and specifically the x coordinates of all points are going to be multiplied by 3. So let's be reasonably accurate again in this graph. Let's graph at y equals x cubed reasonably accurately. Okay. All right. So 0, 0, 1, 1, 2, 8. Oh, yikes. Okay. 1/2, 1/8. Oof. Okay. So this f of x equals x cubed looks like this, I know. Okay, so it looks like this. Oh, well. Make the dot bigger if you miss it, okay? All right, and g of x is going to result in taking f of x and horizontally stretching it. So 0, 0 stays the same. 1, 1, though, look what happens. 1, 1 becomes 3, 1. Negative 1, 1 becomes negative 3, negative 1. Okay? This point here, this point was 2, 8 becomes 6, 8. All right? And you'll notice here what happens is okay. And that's what happens. This is a horizontal stretch. And again, yeah, you can think of a horizontal stretch as comparable to a vertical shrink. But again, what I don't want you to assume here is that a horizontal stretch by a factor of 3, okay, is equivalent to a vertical shrink by a factor of sorry. I don't want you to think that the number involved when you want to say that you want to equate a horizontal stretch with a vertical shrink, that scale factor is not always the same number. And in fact, I will address that issue of like, how do you convert comparatively between a horizontal shrink and a vertical stretch and vice versa, okay? All right, that is the homework. That is a screencast for today. Here is your homework. There are 3 parts. Number 1, you are to do page 145, numbers 30 through 34 all, okay? Also on page 144, above that blue line in the center of the page, above the blue line, I'd also like you to do 12 through 16 all, okay? These questions here ask you to find the domain of a function from a graph. And then I want you to then revert to your pre-calculus handout. Remember the handout that was attached at the very top? It says pre-calculus. It's with the functions with f and g. I want you to actually finish that handout. So the top half of the graph asks you to describe in words how you get g of x from f of x. That's for the top 6. And the 7, 8, 9, and 10, they ask you to actually sketch those graphs. And I would like those sketches to be on reasonably accurate paper, okay? So that is it. All right, I'll see you tomorrow. Goodbye.